Good evening, Ramchand. Today we will discuss about major challenges of machine learning professionals. Okay,
Yes, sir.
so what are the machine learning challenges are there in the industry level? If you see, there are five challenges like poor quality of data. What is data? Data is a raw material. Data may be a different types, maybe audio data, video data, text data, graphics data, any kind of data. Then, what is meant by underfitting of training data? I'll explain. Overfitting of training data and lack of training data and imperfections in the algorithm when data grows. And these are the few more challenges like difficulty in feature, insufficient data, poor generality of the algorithm, poor model interpretability, high degree of research specialization, difficult in feature like we are classifying the data, relationship establishment, recognition, etc. Then data preparation is a challenge, model training is a problem, model deployment is a problem. Let me check these five types. What is meant by poor quality of data? Once we are create data, it is inconsistent or incomplete data can lead to misleading model predictions and unreliable results. That means if you have a data, that the data is a good data, automatically you are expecting good results. If the data is a poor quality, inconsistent, incomplete, so definitely same type of you are getting outputs. Then underfitting of training data. What is meant by underfitting of training data? One second, Ramchand. A few students are. So, underfitting is nothing but when a model is too simple to capture the underlying patterns in the data, it results in poor performance in both training and test sets. That is called underfitting data. When a model is too simple to capture the underlying patterns in data, that means the data set is very small. Then how you are expecting very good patterns from that? That is called underfitting of training data. That means data is small, Ramchan. Underfitting means data is small, and that's why we are getting poor performance on both training and testing data. Then what is meant by overfitting of training data? When a model learns noise instead of meaningful patterns, it performs well on training data but fails to generalize to new data. That is the problem. Overfitting means so we are getting like one second. So, overfitting means when a model learns noise instead of meaningful patterns. Okay, it performs well on training data because data set is very big data set, but fails to generalize to new data. Suppose if you are giving any new data, it cannot perform very well because of um, what I can say because of overfitting. It cannot generate new data for testing. That is a problem. Okay. So now what can we see? Lack of training data means insufficient data can prevent the model from learning patterns effectively, leading to high variance and poor predictive accuracy. That is called lack of training data. That means we have very less data and we are performing uh, if you have insufficient data can prevent the model because Okay, so that is called lack of training data. It leading to high variance and poor predictive accuracy. You cannot expect very good accuracy from that one. That is called a lack of training data. Then what about imperfections in the algorithm when data grows? As data scales, some model is nothing but simplified version of the reality. It struggles to maintain efficiency and accuracy, requiring optimization and robust techniques for handling large data sets. So, these imperfections in the algorithm is not good, but some models cannot perform very good. That's why we are choosing alternative model because of imperfections in the algorithm. Then what are the machine learning libraries we can see in the year 2025 according to machine learning? We have top 10 models like um, NumPy, you know very well, numeric Python. It can perform all numerical operations. SciPy, scientific
Scientific
Python.
Python.
Yeah, it can perform all scientific related operations. Scikit-learn, it is a library. It can perform machine learning concepts like classification, clustering, regression, outlier detection, recommender engine, etc. Theano is a library for artificial intelligence we are solving. TensorFlow is a very big library.
For
The
data
size also.
mining, for data mining,
Uh,
deep learning.
yeah, correct. Big data and deep learning problems we can solve. Keras is a library. It is also can solve big data, machine deep and AI problems. Then PyTorch for especially for machine learning problems. It is a product of Facebook company. Pandas is a library. It can perform on various data sets for describing data sets like how many rows, columns, total, average, standard deviation, variance, etc. We are performing. So why Python for ML? It is more flexibility because we can use any domain irrespective of specialization. Then we can use Python libraries. We can solve. That is called a more flexibility. Code simplicity means we are not writing very big codes because here libraries are playing a vital role. Visualization ability means with help of matplotlib, we are creating n number of graphs, visualization part. Platform independence means you can run in Windows platform, you can run in Linux platform, you can run on Macintosh, anywhere. Better libraries, we have n number of libraries. Then a larger community means number of people are sharing their views and patches into existing Python software. Then these are the machine learning algorithms like first linear regression. The diagram shows slope description, the best fit in through all data points. What is the advantage of this linear regression? Easy to understand. You can clearly see what is the biggest drivers of the model are. Then what is the disadvantage? Sometimes too simple to capture a complex relationship between variables and a tendency for the model to overfit. That's why we are going for logistic regression. The diagram shows sinusoidal wave and based on ones and zeros, true or false, on and off, we are performing logistic regression. The adoption for linear regression to problems of classification and easy to understand, sometimes too simple to capture complex relationship between variables, tendency for the model to overfit. That's why we are going for a decision tree. Decision tree based on the root node and child nodes, we are solving the problem. A graph that uses branching method to match all possible outcomes of a decision. Easy to understand and implement. Not often use of list own for prediction because it's also often too simple and not powerful enough for complex data. That's why we are going for uh, random forest. Next, better technique. Then random forest based on the decision tree concept it is performing. It takes the average many decision trees. That's the greatness of random forest. It takes the average of many decision trees concept. Each tree is weaker than the full decision tree, but combining them we get better overall performance. That's why random forest is a classification technique, very powerful technique. So nowadays in environmental PFAS prediction, groundwater contaminants, and in air pollutants, and soil pollutants, and even crop pollutants. In order to find out, we are using almost all 90% of random forest only. It is giving very good results. That's why the advantage of random forest is a sort of wisdom of the crowd tend to result in very high quality results because combinedly we are using the average of many decision trees. Fast to train, yes, comparatively decision tree. Then can be slow to output predictions relative to other algorithms, not easy to understand predictions. Then we are going for gradient boosting. Gradient boosting is nothing but it is one of the classification technique. It uses even weaker decision trees that increasingly focused on hard examples. High performing, then disadvantages, a small change in the future set or training set can create radical changes in the model. Not easy to understand predictions. Neural networks, we are using uh, neural networks is a classification technique. It mimics the behavior of the human brain. Neural networks are interconnected neurons that pass messages to each other. Deep learning uses several layers of neural networks to put one after the other. That's why neural networks better than gradient, random, decision, logistic, and linear regression. Can handle extremely complex tasks. No other algorithm comes close in image recognition. That's why neural networks are a stepping stone to implement CNN, ANN, artificial neural networks, convolutional neural networks, recurrent neural networks, long short-term memory networks, etc. Very, very slow to train because they have so many layers. Input layers, hidden layers, activation function layers, dropout layer, and fine-tuning parameters layer, bias, etc. That's why it requires a lot of power, almost impossible to understand predictions. Then we are comparing most popular learning software tools. Scikit-learn we are using for Linux and Mac OS Windows. It is a free languages. It can support Scikit-learn, Python, Python, C, C++. Algorithms, we are performing classification, regression, clustering, pre-processing, model selection, dimensionality reduction. PyTorch is a library. It can support platform like Linux, Mac OS, Windows free, Python, C++, CUDA, and then it can perform AutoGrad module, Optim module, neural network module. TensorFlow for support the platform in Linux, Mac OS, Windows. It is a free open source software. Python, C++, CUDA provides a library for data flow programming. Veka is a tool, Vaikato Environment Knowledge for Analysis. Veka came from Mecca. Mecca is a flyless bird at Waikato University at New Zealand. Two professors invented Veka tool for data analysis purpose. It can support the platform Linux, Mac OS, Windows. It is a free operating, free. It supports only Java and algorithms like data preparation, classification, regression, clustering, visualization, association rule mining, etc. Then a NIME. NIME is it's a knowledge mining engineering. It is a tool for data analysis and platform supports Linux, Mac OS, Windows. It's a free. Java supports, can work with large data volume, supports text mining and image mining plugins. Colab, Google Colab. Google Colab is a library environment where we are executing number of programs in Python. It can support a number of libraries already installed and built. It can support cloud service because we are executing online. Without internet, you cannot perform a collab. It's a free, supports libraries of PyTorch, Keras, TensorFlow, and OpenCV, etc. Apache Mahout is a big data tool. It can execute in the platform, cross platform. It can support anywhere, free and Java and Scala. The algorithms like preprocessors, regression, clustering, recommenders, distributed linear algebra. Acars.net is a cross-platform free C Sharp. It is a product of Microsoft company. Classification, regression, distribution, clustering, hypothesis test, and kernel methods, image, audio, and signal and vision. Then Shogun. Shogun is one of the tool. It can support in the platform Windows, Linux, Unix, Mac OS, free C++. It can support only one language, Shogun. Algorithms are features like regression, classification, clustering, support vector machine, dimensionality reduction, online learning, etc. So Keras.io cross-platform. It is free Python application programming interface for neural networks. Rapid Miner, it is one of the data mining tool. Cross-platform, free plan small, Java, data loading and transformation, data pre-processing and visualization. So top 5 classification algorithm in machine learning: logistic regression, decision tree, support vector machines, naive-based classification, k nearest neighbor. If you see a few more algorithms like class in machine learning, we have concepts like classification, regression, decision tree, clustering, collaborative filtering, frequent pattern mining. We are using a priori and FP growth algorithms, statistics, model, persistence. Then we have algorithms like logistic regression, decision tree, support vector machine, naive-based classifier, artificial neural networks, k nearest neighbor, etc. So what are the top 10 major and machine learning algorithms? Like linear regression, it is a supervised learning algorithm for modeling the relationship between dependent variable and one or more independent variables using a linear equation, y is equal to mx plus c. Logistic regression, it is a supervised learning that is used for binary classification. Keep in mind ones and zeros, whether true or false, on and off. So it binary classification problems by modeling the probability of categorical outcome. Decision tree, it is a supervised learning algorithm that splits data into branches based on feature values, creating a tree-like model for classification or regression task. Support vector machine is a supervised learning that finds the optimal hyperplane to separate data points in a high dimensional space for classification or regression. K nearest neighbor. It is a simple non-parametric supervised learning algorithm that classifies data points based on the majority class of their nearest neighbors. Naive Bayes is nothing but a probabilistic supervised learning algorithm based on Bayes' theorem, assuming independence among
So
features
the
for
example is
classification tasks.
text classification and spam detection, isn't it?
Yes, yeah, yeah.
Yes.
Yeah, you can consider and we can perform. K means clustering is a clustering algorithm. It is unsupervised learning because we don't know the label, we don't know target class. Based on the similarity measure, we are classifying the data. That partitions data into K clusters. K means assumptions. We are assuming number of clusters. Maybe K is equal to 3. Based on feature similarity, we are classifying the data. Random forest is a extension of decision tree. It is the average of number of decision trees, and it is a supervised learning algorithm that combines multiple decision trees to improve classification or regression accuracy. That's why random forest is one of the powerful technique. Then we are going for gradient boosting, that is called XZ-boost, light gradient boosting method. A powerful ensemble algorithm that iteratively builds decision trees to minimize errors, widely used in machine learning competitions. Then we are going for deep learning, deep neural networks, that is convolutional neural networks, recurrent neural networks. These advanced algorithm leveraging means integrating multiple layers of interconnected neurons to solve complex problems like image recognition, time series analysis, etc. So we have already, first we'll see the top 10 5 algorithm. Logistic regression is a statistical model that in its basic form uses logistic function to model a binary dependent variable. All the many complex extensions exist. It is estimating the parameters of logistic model in the form of binary regression like ones and zeros, true or false, on and off, etc. Logistic regression is used when the dependent variable is binary in nature, like 0 or 1. Logistic regression measures the relationship between the categorical dependent variable and one or more independent variables by estimating probabilities using a logistic function, which is the cumulative distribution function of a logistic distribution. This is the difference between linear regression and a logistic regression. See here, in x-axis we are having valid points. In y-axis we are measuring the data. Whereas in based on the slope y is equal to mx plus c, here also we are using y is equal to mx plus c, but the output is 0 or 1 in the binary form in the nature. That's why logistic regression algorithm uses input x1, x2, x3, x4. Then we are performing a linear model like a probability 0.5 to 0.8, 0.1, 0.2. We are using activation function called sigmoid. Then the values between 0 and 1. If the output is 1, then we can say the variable is presented or the row is presented. If the output is 0, the row or instance is false. Then this is the program logistic regression. We are importing matplotlib as pyplot as a PLT, import numpy as NP. From sklearn, we are from scikit-learn directly we are importing logistic regression. From sklearn, we are using a classification report, confusion matrix we are generating. Import matplotlib, we are using for graphs generation. X-axis, we are taking np.arrange 10 points dot reshape of -1, 1. That means 10 values we are taking as input, rows becomes columns, columns becomes rows if you are performing reshape -1, 1. In Then we are printing x value, y value. Model directly we are using logistic regression. Solver like library linear, random state 0. We are fitting the model fit, model dot fit of x comma y. We are using logistic regression directly with the fine tuning parameters like classification 1.0, class weight none, dual false, fit intercept true, intercept underscore scaling 1. So L1 ratio none, maximum iteration hundreds we are performing, multi-class 1, number of jobs none, penalty L2, random state 0, solver library linear, total value 0.0001, verbose 0, warm test false. Then we are printing the predicted classes, model class, intercept value, quotient value, predicted values, and we are getting a predict a probe of x plt dot show. So let me execute this program. So logistic.py, if you run this program, I'm sharing in your WhatsApp also. Once let me execute
Okay,
first,
sir.
Ramchan. You need to execute this program. Notepad space logistic.py. Let me check whether the program is there or not. Yeah, write a Python program to perform logistic regression, same program. Okay, just now we have explained Python space logistic. So based on our input data, 10 values we have taken. So which values are ones, it will classify. Which values are 0, it will classify. So it is running based on our logic. According to logic, it will execute and it can perform. See. So first we have taken the values like all we have taken in the column wise. Now row wise it came. Again column wise we have printed. Predicted classes 0, comma 1. Intercept value is minus 1 point. Coefficient value, predicted value. So dependent variable and independent variable, the values we are getting based on the values x-axis and y-axis. If you want to label also, you can insert. So I'm sharing this code through WhatsApp, Ramchand. Can you
Yes, sir.
execute? So I'm sharing 1 second. Yeah, you can execute. Yeah, you can share your screen and
Right, sir.
execute. You can share
Okay, sir.
and
Okay.
execute. I have shared in WhatsApp. Your screen is visible? Yeah.
Yes, sir.
Yeah, you got it. Perfect. So next we'll go for see my recording section where
Next,
it gone. I
continue,
don't
sir.
know, Ramchan. Yeah, I don't know. So suddenly it disappear. So where it is stored, I don't know. Is there any problem? I don't know. Huh? It's okay. After
Okay,
this
sir.
session, you can share me. Okay. So next we'll go for a decision tree. Decision tree is a flowchart like tree structure where each internal node, that is non-leaf node, denotes a test on a attribute. Each branch represents an outcome of the test, and each leaf node or terminal node holds a class label. Decision tree induction is developed by Ross Quinlan, actually. Okay. So So decision tree induction is developed by Ross Quinlan, and it is called ID3. ID3 means iterative dichotomizer 3 version. We used to call it as. Okay. So then a decision tree is a classifier in the form of, okay, in the form of a tree structure, decision tree, like leaf node, decision node. It specifies a test on a single attribute. Leaf node is indicates the value of the target attributes. Arc edge is nothing but it's a split of one attribute. Path, path is nothing but a disjunction of test to make the final decision. Then classification by decision tree induction consists of 4 steps like decision tree induction, attribute selection measures like information gain, gain ratio, Gini index. Which see we have number of columns. Which column is having highest priority? How do we can calculate based on the information gain and the gain ratio, Gini index. Tree pruning, we are eliminating noisy data with help of uh, tree pruning, then scalability and decision tree induction. So this is the data set, Ramchand. We have studied in data mining and data warehousing. Data set in all electronics customer database. It is the name of the data set. It is in Excel format, or you can write in a CSV, no problem. And record ID, age, income, student, credit rating, class is by computer not. The aim of this data set is there are 3 categories of age people. Which people can buy the computer? That's all we need to find out. It is a small data set, you can say. If it is lakhs of records, how do you can say? That's why we are going for a decision tree
Yes,
algorithm.
sir.
Are you understanding, Ramchan? So if youth income is high, student no, credit rating fair, then still he is not purchasing computer. Then youth high no, excellent no. Middle-aged people high no, credit rating fair, yes, he can purchase. Senior, medium, no, fair, yes, he can purchase. Likewise, number of records are there. So based on this condition, age, okay, based on the age it can take the directions like youth, student no, student yes, middle aged yes, senior, credit rating fair, still is not able to purchase, excellent, purchase. A decision tree for the concept buys computer, indicating whether a customer at all electronics is likely to purchase a computer. Each internal non-leaf node represents a test on an attribute. Each leaf node represents a class, either buys computer yes or buys computer no. So this is the program, Ramchan. We are in number of libraries, pandas, numpy, matplotlib, cborn sklearn. Then directly we are using a data frame from reading the data from iris data from internet. Then head node we are finding. Then we are getting information of data set. Info means we are getting data set information. Then shape. Then is null. Any blank or no data is there, that time we are using the function is null. Then it will keep all the null values. Then SNS pair plot we are generating. Heat map also we are generating, that is correlation matrix. Then target species, and then a data frame we are copying. Then we are performing define the attributes, label encoding, defining the decision tree algorithm, predicting the values of test data. Then we are visualizing the graph without the use of graph which plot figure 20 comma 20. Likewise, we are executing this program. See here, we are executing this program and we are getting the number of iris data set through internet. It can collect the data, then it can perform automatically. It can decide the accuracy, number of samples we have taken, and how many are correctly classified and how many are wrongly classified. It can decide. Okay, so decision tree and random forest, this one. Remaining algorithms, these are so
Okay, sir.
5 algorithms are Ramchan.
Okay, sir.
You can try with your, no problem. I'm sending this PPT. I
I
think
think
you
one
have
week
this
before you
PPT.
said we.
Yeah, today again I will send.
No
I'm
problem, sir.
tired.
Please take
Can
your
I
rest, sir.
stop
No
here?
problem. Thank you, sir.